If you've ever produced professional live sound or broadcast, you know the single biggest logistical nightmare. It's distance.
Oh, absolutely.
Running broadcast quality audio over traditional copper XLR cables means you're just fighting signal loss and noise the minute you pass a few hundred feet.
Exactly. And that whole headache is the core problem that systems like this are designed to solve. Today, we're diving into how tools like the Thor Broadcast F-2A-XLR-TxRx kit, well, how they completely changed the game.
Okay, let's unpack that. We're essentially swapping electricity for light here. What kind of practical difference are we actually talking about?
The jump is, it's radical. With copper, you're lucky to get a few hundred meters before you start getting noticeable quality loss.
Right.
With fiber, the baseline for a single mode run is 20 kilometers.
20 kilometers, that's about 12 and a half miles.
12 and a half miles.
Uh-huh.
And if your job needs it, for a huge broadcast link or something, there are options for 40, 80, even 120 kilometers.
That is just an astonishing range. But here's the critical question. Does the quality hold up at those distances?
And that's the whole point of digital fiber. It doesn't degrade. The signal stays 16-bit digitally encoded broadcast quality.
So the key specs hold up.
They hold up perfectly. Your frequency response is rock solid from 10 hertz to 20 kilohertz. And the signal-to-noise ratio, get this, is better than 80 dB.
Okay, so for the broadcast folks listening, let's talk about that. Why is that 80 dB SNR and that 16-bit 48 kilohertz standard so important? What's the real-world fidelity there?
It means silence is actually silent. With an SNR of 80 dB, the background electronic noises, it's just non-existent to the human ear.
Got it. No hiss.
No yes, no hum. And 16-bit at 48 kilohertz is the fundamental standard for digital audio. So this system guarantees that whether your mic is 20 feet away or 20 kilometers away, the audio hitting the mixer sounds identical.
So the takeaway is, if the venue is huge, a stadium, a big concert, a theme park, this is the invisible backbone making it all possible.
Precisely. Now let's talk about the hardware itself. It's all standard 3-pin balanced XLR inputs and outputs.
So it's plug and play.
Totally. It's designed to slot right into existing gear.
The specs are clear, but how does a system like this handle, say, a massive stadium show? You might need dozens of mic channels.
And scalability is absolutely key there. The entry-level unit handles 2 channels, but you can get it in options for 4, 8, 16, even up to 32 XLR inputs and outputs on one transmitter.
32 channels.
Imagine running 32 channels of pristine audio over one tiny fiber optic cable instead of, 32 massive copper reels.
What's really interesting to me are the bi-directional models. I see the 2 and 4 channel kits can send and receive at the same time over a single fiber.
Yeah, that's wavelength division multiplexing, or WDM.
And for the engineers setting it up, what does that practically save them?
It saves you half your fiber budget. You're using 2 different colors of light, essentially one at 1310 nanometers and another at 1550 to send data in opposite directions down one single strand of glass.
So you only have to run one cable.
You only run one cable. It streamlines setup. It reduces potential damage. It's a huge deal in a busy venue.
And finally, the physical connectors. I see the standard is STPC, but you can get SC or FC. Why does that choice matter?
It's mostly about stability and what's already in the building.
Yeah.
The S-key connector is a twist lock. It's very rugged, great for rental and staging.
Right.
The SC is more of a simple push-pull. You just order the connector that matches the infrastructure you're plugging into.
So wrapping this up, what it all means is that professional audio today really relies on these specialized fiber kits. They bridge vast distances up to 20-kilometer standard while keeping the signal absolutely pristine.
And they do it with the flexibility to scale up to 32 channels. It's a technology that makes modern, large-scale remote production even possible.
That brings up a really interesting final thought. We focused entirely on audio here, but you're running light down a pipe with massive capacity. What other critical signals like uncompressed 4K video or camera control data could be riding on that exact same fiber?
That's the key question. The moment you lay that fiber for audio, you open a door. You can multiplex every single signal you need for production. The audio run is just one part of a much bigger light speed network.